Okay, so assuming that you have been practicing, this shouldn't have taken more than maybe 2 minutes. Okay, what is the domain of a curve that starts from the x value of 0, right, as well as the y value of 0, of course, it's, the point 0, 0, and it continues to move in the upper right direction. So the first quarter of the graph, right? So quadrant 1 is what we call it. Now, being domain, starting with a squiggly line, it's gonna talk just about the x values. And so I start at an x value of 0. And how far right is this curve going? Yep. Infinite. Absolutely. So you can say x is from 0 and it goes to infinite. Okay. You can do that. So you can say x could be any number such that x has to be between 0 and infinity, but we don't really write infinity as a domain. We really don't write that. Instead, if I said you can't do infinity, in other words, this I don't want, what's another way you can express the x value? Mike?
X is greater than or equal to 0?
Sure. That's all you have to say, really. X has to be just bigger than that, right? So, use the same, I guess, pick or same little sheet that I talked about yesterday. You can write the smaller number here. You can write the larger number here, and you always write that symbol. If the symbol is confusing you, there it is. X has to be bigger than 0, or 0 is smaller than or equal to x. By writing this, it automatically does not allow any of these x values to happen. That's it. Yep.
I know you always put the smaller number first, but technically you can write it.
Correct. You can write this. Right? X is bigger than, so the mouth portion, and then the arrow points to the smaller side. You can do that too. In the same breath, take a look at the y values. In other words, the range. The y value starts from 0 and it goes up forever. It definitely doesn't go down forever. It actually stops right at the 0. So, someone want to use the first example and try to mimic how we would communicate the range? Be wrong. I encourage you. Take a shot. Okay, Charlie, go ahead. Yeah. Such that. Oh, y has to be smaller than 0. Like this? Well, talk to me in words. Does the y increase in value? In other words, does it go to the positive direction, or does it decrease in value and go in the negative direction? Positive. Okay, so how do we communicate that it's gonna continue being positive? It's gotta be a positive. How can we write that mathematically? Sage? Yeah, so y can be bigger than or equal to a 0. It includes a 0, of course. That's why I did the dot there. We could do it that way, or if you want to use how I do it just to save time, I write the smaller number first, which is a 0. And the larger number is infinity, right? So like it's whatever the y is, it's larger than a 0. So I write it like that. But if you write it this way, as Michael was saying as well, it's totally fine. As long as the sign is correct, you can do it any way you want. All right. Please recap. Please be careful. And also part of yesterday was doing the finite differences. So I hope you get a chance to review that through your textbook homework. Would you like more practice with domain and range? You want another one to see if you can do it? Sort of. We got half of you saying, yeah, half of you is like, not so much. All right, here we go. Here's another interesting graph. Okay, like easy, medium, or hard? All right, I'll give you one medium and one hard. And then we'll move on to today's lesson. I can afford to do this today because today's lesson is actually pretty straightforward. It's all about function notation. Here we go. Here is your medium. Okay. And here is your hard. So many ways I could do a hard. Sure. Okay. I'll just do this one. All right. So just to give you some context, for this one, it will go up forever in the upper left, I guess, upper right corner. And this one will also go on forever in the X direction, but it actually never touches the X axis. Okay, it will never touch Y equals 0. So think about that. For my hard one, I have a curve that goes up and down and up and down and up and down. There's an actual curve like this. We're going to learn it this year. So I might as well throw it at you. It actually never goes past a height of 1. It never goes under a height of -1. It does touch, however. It does touch it, but it doesn't go past it. And it goes forever in the left and right direction. So what would be the domain and what would be the range of both of these? I'm going to give you 5 minutes simply because you've never seen this graph before. But remember, domain and range, the how you do it and what you look at and all of that stuff doesn't change. The language, the symbols, it doesn't change. So consider this to be, hard mode for your quiz. I will pause the video, giving you an opportunity to try this. Okay, so a couple of things that you might find interesting about this graph. Not interesting. You just have to be very careful of what we're talking about. When we do domain, we are strictly looking at how far left and how far right. In other words, what are the X values that we are dealing with? Okay. And in this case, this arrow goes forever left. And in the right direction, yes, it's going up, but think of it as like a plane. Okay. Okay, as a plane, it's going to continue to go in a particular direction and move along until X gets to infinity. And so it goes left infinity and right infinity. The domain is actually just X could be any number out there. That was it. It might look weird, but if you try to imagine it just based on left and right, that's your domain. But what about range? I'll start us off. Okay, y could be any real numbers because this is all solid. Just every single possible y value is there. Every decimal is okay. But yes, y goes to positive infinity. How low does it go? It'll go low. Can it be a 0.1? Probably. Can it be a 0.01? Probably. Can it be a 0.0001? Probably. What can it not be? Cameron, I'll let you take this.
Can't be a zero.
It can't be a zero. So how do we say the y could be anything as long as it doesn't go past a certain point? Yeah, go for it.
Would it be as long as y is greater than zero?
Correct. So I'm going to write, so I could do y is bigger than zero, not bigger than or equal to, good morning, just bigger than. So I could do zero, bam, bam, and you're done. Okay. Next one, I'm going to go a little bit faster. So I'm going to just quickly ask someone to volunteer their answer. Just give it a shot. Anyone? Someone else? Just ask yourself, Maria. Yeah. Yeah, it's got to be bigger than -1, smaller than +1. How do we say it's got to be in between? You might like this. You write the smallest number here. You write the largest number here, and you say the y value has to be between it. Right? It has to be between. And of course, to show that it has to be between, we need to add the special symbols. There it is. Y is between -1 and 1. And this mask has to be the most uncomfortable thing I've ever had. How does the TDSP give me this? Yeah, Charlie. Um, 99, I'm gonna say it right now, 99% of the time, it'll always start with X belongs to real numbers, and then you give me your condition. Any restrictions or conditions that you have. Yeah. On a quiz, for example, I might have tried to make it easy for you. What if I give you a function that's represented by 1, 1, 2, 2, and 3, 3? If I do that, what would domain be? Someone else, Max. Yeah, if I'm just talking about x's here, what are the x values for this function? So here is 1 point, here's another point, and here is another point. What are the x values for that? No, just the x values. What's the x value between these two? Which one's the x? Right, and what's the x here? And what's the x here? The first 3, yeah. So the domain for this function is just 1, 2, 3. Right? And the range for this one, I just happen to make it easy, is also 1, 2, 3. But if that was like 4, 5, and 6, my range would be 4, 5, and 6. Domain and range simply is talking about what's the x and what's the y. Whatever is easiest for you, use that. But it has to be accurate. That's all. Any questions? This is domain and range. Yes, Mike. Yeah, go for it. Write your name. All right, let's do today's thing. Today's lesson is actually just a very quick repetition or revisit to what we started yesterday. So I'm going to stop here and show. Okay. There's a bit of a blurb to try to get you to understand, even if you missed today's lesson, this should get through the most of the material. So I hope it'll be useful for you. In short, if you're given an equation like this, y equals x squared plus 2x minus 3, we can rewrite it as f of x, which is x squared plus 2x minus 3. Why is that useful? It's very, very easy to communicate certain calculations that we want to do. Like, for example, let's pretend we wanted to figure out what the y value is when x is a 3. Instead of writing y equals x squared plus 2x minus 3, and then x equals 3, we can actually simply rewrite it as f of 3. This part right here represents not f multiplied by 3. That's not what it represents. It represents what does the function equal to if x is replaced, my writing is terrible, with a 3. That's what it means. So every time you see an x, I'll highlight this for you. Every time you see an x, you're going to plug in a 3. Every time you see an x, you're going to plug in a 3. Every time you see an x, you're going to plug in a 3. Yes, Sam. Go for it. So take a look at what that means. F of 3 will equal to x squared 2 times x minus 3. And the rest is BEDMAS, which goes back to your elementary, middle school, and even high school skills. Okay, and I'm going to say it right now. Some people are still going to be a bit tripped up by a certain BEDMAS thing. So there comes more practice. If you don't do the practice, well, we can't improve. Don't be afraid to fail. Don't be embarrassed to be like, oh, I should know this, but I don't, so I'm not going to. Don't be like me. Here's what I'm going to say. All right, just start somewhere and just keep moving forward. Here we go. More than me just talking more and more about what it means and how to do it, let's do it as an example. We'll start with an easy one. Okay, so again, as a repetition, f of 3 means what's the value of the y if x equals 3? Another way you could read it is f of 3 means if x equals 3, what is the ordered pair x and y? Find y. Here we go. Here's my f. Here's my function. X squared, 5x minus 24. Solve for f of 0. So you would write f of 0 is equal to 0 squared plus 5 times a 0. Sorry, I'll do that. 0 squared plus 5 times a 0 minus 24. That's it. So anything 0 squared, obviously the 0. I'm not even going to write it because I'm a mathematician and I'm lazy. 5 times 0, it's a 0. I'm lazy. I'm not going to write it. And negative 24 is all that's left. There's your answer. So therefore, if x is a 0, my partner is negative 24. That's 1 point on the graph. That's it. If you get this as a system, if you're like, oh, that's really self-explanatory, you can do the rest of this page as you see fit. It's just a matching game. If you want to see it one more time, let's take a look. The next question says solve for f of 1. Remember, f of x is x squared, 5x, negative 24. So f of 1 is x squared, x squared, 5x minus 24. Anytime you see an X, you plug in that number. And so we have 1, 5, negative 24. And at this point, if you want to use a calculator, by all means, the answer will be negative 18. Therefore, 1, negative 18 is on the graph. So X is 1, Y is negative 18. They go together. So this is why the textbook calls it the F machine, right? Like, but you get the point. You plug in a number, you get a number out. Right? You put in one number, you get a number out. Could I, shall we do one more? Yeah, just to get the example. Here's another function. It's completely different. I'll leave f of 0 for you because I think you can do it. Let's do the hard one. Find f of 0.5. So it's a weird number, but that's okay. Remember, f of x is negative 3x squared minus 4. So that means f of 0.5 is 3 times x squared minus 4. But of course, not x. We can plug in there. Right? If the x is 0.5, you plug in 0.5. Yes. Nothing. Solve means answer, I suppose, or calculate. Find is essentially saying find the y value, which is essentially the same thing. It's probably my fault for forgetting. So 3 times, so remember BEDMAS. Exponent comes first. 3 times 0.5 squared. 0.5 squared should be 0.25. And then BEDMAS, multiplication. And then BEDMAS, subtraction. Done. That means if the x value is 0.5, my y value is negative 3.25. That's what it means. That's what this means. The rest is really just practice. There's nothing new, but please note, the rest of this semester, this course is called Functions and Applications of the Functions, which means this notation will be everywhere. Like, close your eyes, grab your textbook, and open it up at a random page, and you'll see these notations. It's the rest of the textbook. So it's in your best interest to be very, very quick with these functions. Like, just understand what it means without even thinking. Get to practicing. Yes, Fatina. Yes, well, pretty much to the T. Right? It covers everything that it needs to, and there was no need to update it like we did in grade 9. Speaking of textbooks, Fatina, did you take one? Okay, I need your code. Yes, go for it. Natalie, are you here? No? Okay, so let me get that code. Okay, and that's essentially it, everyone. So take a look. I have some harder functions for you, right? With harder numbers. I have a weird function with a fraction, but that's okay. I'll do one together. The rest is just problem solving. So I'm going to do some spot questions here on the back page to alleviate your homework a little bit. And then the rest of class is yours to use. What is your code? 8-14. They're all numbers. 14. They're all numbers. All right, let's try one of these weird ones. This time the function is a fraction. If you get to grade 12, you may see these. Okay. Here we go. solve for f of 4. So f of 4, essentially, it might look hard, but the math is still the same. Every time you see an x, you put in a, yeah, that's it. That's it. And so we have 4 plus 3 over 4 minus 3. And of course, being BEDMAS, right? Like you have to do the brackets before division. Please note, numerator and the denominator, they're separate. 4 plus 3, 7. 4 minus 3, that's a 1. Your answer is a 7. So this tells me that the point 4, 7 is on this weird graph. Yes?
So I was gonna ask about 4B.
Or
Square brackets. What's up with that?
you mean 5b?
Oh, 5B? Oh, 5B.
5b. Yeah, I was going to do that next so that it doesn't confuse you. Some people, they're like, I've never seen this form before. I'm not going to do it. Okay? If you've done a lot of BEDMAS in grade 9 and grade 10, you might have come across these square brackets. These square brackets are literally a second set of normal brackets. In fact, it's not necessarily main. The most common ones are these curved brackets, and the proper name is parentheses. Anyone heard of that before? Yeah, right? So in the States, actually, they don't call it BEDMAS. They call it PEDMAS. Yeah, potato, right? Really? So what this means is literally just do f of 1, and then that is multiplied by g of 2. That's all it means. It's just a second set of brackets, and it wants to distinguish between the curved ones, so it made it into square. If you don't like those square brackets, by all means, make some larger brackets so that your eyes won't get confused. All right. So first, for this one, find what f of 1 is, and then find what g of 2 is, and then whatever the two answers are, just multiply it. So here we go. I will do f of 1 here. F of 1 is 1 minus 3. And I'm going to do mental math. I'm not even going to write 1 minus 3. You can do that in your head. I hope. I think you can do it. 1 minus 3. Next, g of 2. This might be a little bit rough. 2 squared plus 2. 2 squared plus 2. 2 squared plus 2. Use your calculator, whatever. 2 squared plus 2 is a 6. And so if the question is asking, what is f1 multiplied by g of 2, that is the same as saying, what is negative 2 multiplied by a 6? And the answer is negative 12. Function notation has its benefits. If I wanted to write this, how would I write it using normal communication skills, like without these symbols? Wouldn't it be like this? Wouldn't it be solve this, right? Because this is f of x and that's g of x. Multiply f of x and g of x, but this x is a 1 and that x is a 2. Like that's pretty confusing, right? And so it makes it very efficient as the questions get more and more complex. So I hope you're buying into this, that you're going to be okay with this kind of notation throughout the rest of the semester, and do this sheet for me. Yes. Oh, it's right here. The question actually gives it to you. Yeah. Given, if I gave you f and g, go solve the rest, is what their question says. Yes, Maria. Yes, there it is. G of 2, remember the function g is x squared plus 2. So g of 2 is 2 squared plus 2. Yeah, which is 4 plus 2. Okay, yes, Charlie. Correct. So same idea. I want f of 0 added to g of 0, so you can find each of them separately and then add them together. And that brings us to the end, really. Finish this page for sure. I like to see that you are working hard on function notation. It might be a little more fun than finite differences. There are some textbook questions. Again, I'm trying to shorten the amount of questions I give you. Numbers 1 to 4, 6, and 13a. So those are 6 questions that you can try as more practice. If you want to write it here instead of your agenda, would you please also write this? Bring text tomorrow. Tomorrow is going to be all a textbook thing as a mid-chapter review. Nothing new. We're going to prepare for our quiz. Right? And then quiz Friday on 1.1 to 1.2. Okay. The rest of class is yours. I wish I gave you some more time, but we spent a lot of time doing the domain and range, which I think is good, valuable time. Please use the rest of time as you see fit while I do some, yeah. Any questions? You can come to me. All right, going once, going twice.